All right, today we're going over comparing and ordering real numbers. Oops, sorry. There we go. You're going to be able to compare and order real numbers, and your essential question is how to know where to start when solving the problem. So I want to make sure we understand some keywords that we're going to hear, which is least to greatest, and the word used to describe that would be ascending, and greatest to least is descending. So think of an airplane going from the ground floor up into the air. That's ascending from the lowest point to the highest point. And greatest to least, meaning the highest point in the air all the way to the lowest point, which would be on the ground. Okay. Some symbols that we use, less than. So if you kind of notice, you can remember the less than kind of looks like the letter L. It's a little bit squished, and then greater than. Okay. So we're going to go ahead and practice our first example. Okay. So we have 1.3 and 4/3. So we have Desmos, so we're going to utilize Desmos. So we have 1/3, which is already in decimal form. So 1.3. And then we have our 4/3. And so we're going to type into Desmos 4/3. So 4 divided by 3 and equals, backspace. How do you backspace? Let's just do that again. 4 divided by 3. There we go, 1.3. But if you notice, the next number was 3 because it was repeating. So this is 3, 3, 3, 3, 3. Well, what's the next number after this 3? Well, is it a 3? No, it's a 0, which is why there's no value there. So even though these might look like the same, they're actually not. 33 is larger, so we would say 1.3 is less than 4/3. Oops. Okay. All right, and then let's go ahead and try this one. 650%, which you may remember, a percent is always out of 100. So we would type in 650 divided by 100, and that would give me 6.5. And then we're going to take the square root, 6.5. And then we're going to take the square root of 37. And then we got square root of 37. Which is 6.08 or 6.1. So 650% would be greater than square root of 37. Okay, so let's do 5/11 rather. Sorry. So we got 5/11, which is 0.45 repeating. And then 3/7. So I got 3/7, which is 0.43. 0.43. So we got 5/11 is greater than 3/7. Okay. Now we have some some addition with our square roots. So we got the square root of 11. Now you need to use your side arrow keys. Let's see if I can figure out how to get that there. Or just tap over to the right, which is what I did, because I don't have access to my keys right now. That's 18.3. And then let's do the next one, which is square root of 8. Square root of 8. Again, move over to the right, then put plus 15. And that would be 17.8. So 18.3. So square root of 11 plus 15 is greater than square root of 8 plus 15. Okay. Okay, so we have square root of 17. Tap out of it, minus 3. And that gives us 1.1. And then let's try the next one, which is -2. And then plus square root of 5. And that gives us 0.023. So obviously 1 is bigger than 0, so that would be square root of 17 is minus 11 is greater than negative 2 plus 5. Okay, so Desmos does have a pi symbol, so you can do the pi and then hit divided by 6. And that would give me 0.5 or 0.52 or 0.53, excuse me. And then we're going to do square root of 3. Make sure you get out of the square root, then hit divided by 2. If you don't, it will have everything in the square root. So make sure the 2 is not in the square root. And that gives me 0.8. So obviously 0.8 is bigger than 0.5. So square root or pi divided by 6 is less than square root of 3 divided by 2. Okay. Next one. So remember, negatives are different than positive because the larger the negative, it's actually a smaller value. So 0.4 is closer to the 0. So that's actually larger in value because it's closer to 0 versus 0.5. If it were positive, what we're comparing, it would be the opposite. Okay. And then this is similar to what we talked about earlier, 0.3, the next number is 0 versus 0.3 repeating means the next number is 3. So 33 is larger. So we want to make sure we're using a less than symbol on that one. And then we got the square root of 64, which hopefully you remember square root of 64 is 8. And if you don't, you can use Desmos, so square root of 64. Tap out of that and then put divided by 4. That would give you 2 because 8 divided by 4 is 2. And 16, obviously 16 is larger, so you would use the less than symbol. Oops. Okay. And now we're going to be ordering in ascending order. So ascending, if you remember, ascending means the airplane's going up in the air. So it's from the lowest point to the greatest point, so least to greatest. So we want to put them all in the same format. So this is 4.2 and 4.3. So we already have those in the tens place. So we're going to go ahead and stay with the tens place. So we need to convert a couple of the numbers. So we're going to take the square root of 14, which gives us 3.7. And then we have 22 divided by 5. So again, I can use 22 divided by 5. Gives me 4.4. So we want the smallest number listed, 3.7. So we're saying the smallest number is actually the square root of 14 because 3.7 wasn't there. The next is going to be 4.2 repeating. And then we have 4.3. And then our last number is not 4.4, it's actually 22 fifths. Okay, so ascending order. Okay, next one is descending order. So descending order, right? So I'll go from okay, so highest, greatest to least. Okay, so again, we want to put them all in decimal form. So when we do that, okay, we want to make sure that we have them all equal in terms of format. So if you notice, a couple of things we're going to talk about is that we have a tenths place and the hundredths place. So let's put them both in the hundredths place so that we're comparing the same type of number. So we're going to call this 3.50. This is already the same, which is 3.05. So now they're both in the hundredths place. So when we do our square root of 15, we want to put that in the hundredths place. So square root 15, and that would be 3.87. And then 10 thirds. And that gives us 3.33. Okay, now they're all in the hundredths place, so we're going for the highest number because it's a greatest because we're descending. So greatest number was 3.5. Oh, excuse me. Erase that. All right, then the biggest is, right, we're comparing all of the decimal points, 87. So square root of 15 is first, then 3.5, then 3.3 repeating, so that would be 10 thirds, and then the last one, 3.05, which was that's how it was written. Okay. Next one, again, we have to put them all into the same format. So we have one number that was in the tens place, and this is in the hundredths. So let's go ahead and put this in the hundredths also. and then 3.05. Okay, and then we have to convert the rest of them. So let's try 8/3 first. So we got 8 divided by 3, and that is 2.66. And then we have 7/2. So 7 divided by 2. We have 3.5. And we're going to, again, hundreds place, so 3.50. And 2%. Oh, that's 2. And every percent's out of 100. So 2 divided by 100 is 0.02. So 0.02. All right, so we're ascending this time. So that means we're going up in the air. So we're going from the least to the greatest. So the smallest number was here, which was 2%. Then we had 2.50, so 2.5. And then the next one is 8/3. And then 05 is bigger than 50, so 3.05. And the largest number, which came from 7/2. Which of the following best describes the square root of 50? So let's first find out what the square root of 50 is. 7.07. So let's write that down. 7.07. So, well, is 7.07 between 6 and 7? Well, it's bigger than 7, so it's not between 6 and 7. Is it between 7 and 8? Well, that looks right. Let's make sure. Is it between 8 and 9? Well, no, it's not bigger than 8, so no, we're not there. Certainly not these numbers because we're taking the square root. That's if we didn't take the square root, right? So B would be the correct answer. Okay. This one says the table shows the diagonal length of TV screens at a store. Which TV length has the smallest diagonal length in feet? So these are the lengths in feet. So we don't have to we don't have to calculate any lengths. It's already given to us. We just have to figure out which one is the smallest, right? So we're going to have to figure out which one's the smallest. So let's go ahead and take the square root of, I think it was 12.25. Okay, so that was 3.5. Okay, and then 2 1/6. So we haven't done one of those. So let's make sure we can do, we can just do the 1/6 part, which is 0.16. So then we call it 2.16. So all we did was turn in the fraction part into decimal, not the 2. It stays a whole number. 37 divided by the square root of 144. Make sure the square root's correct, 3.08. And then we have 8/3. So let's do 8/3, which is 2.6 repeating. We'll do 6. So it says which one is the smallest? Well, these are 3, so we know it's not either of those. So 16 would be smaller than 66. So screen X is the smallest. Okay. Next one says Jerome's grandmother offered him a TV measuring 30 inches diagonally to use in his bedroom. So let's go ahead and mark that. Make a little picture of that. So this is 30. And then it says his uncle offered him a TV that has a diagonal sticker displaying 625 squared inches. So we want to know if the diagonal is, let's see, so what they're wanting us to do is take the square root of 625 to unsquare it so that this one's in inches. And since this one's inches squared, we have to take the square root of 625. So if I took the square root of 625, I would get 25, which you probably don't know that, but let's make sure you can see that. So it's 25. So this one's 25 inches versus 30 inches. So which one? It says we want the most, right? So we want to get the biggest one. So we're going to ask for the one that's 30 inches versus 625 inches squared. Okay.